All right, welcome back to third lesson in Unit 2. Last time we looked at adding and subtracting radical expressions. We are going to be looking at multiplying and dividing radical expressions. Okay, so before we do that, I'm going to quickly review what a distributive property is. We learned this in math, actually I think all the way back to math 8. But we did learn something. It's a binomial times binomial, so I'll just quickly remind you: a minus b times, or a plus b times x plus y, let's say. So recall distributive property for the binomials will be a times x, a times y, b times x, b times y, right? That's the distribution property. Of course, it could be longer, right? It does not have to be just binomials. It could be binomial times a trinomial. Let's say if we added a z there, you just need to make sure that you multiply the first term with every single term in the second bracket, and the second term in the first bracket multiplied by every single term in the second set of brackets, right? Like that. So you distribute, right? You make sure you multiply with every single term at least once. Or just once, I shouldn't say at least once, just once. Okay, so I call that the rainbow. Okay, doesn't really matter what you call it, but that's the distribution property. Okay, so the first one, again, quickly review. Distribution property here tells us that we need to multiply 3x with 3x, which is 9x squared. 3x times 1 is plus 3x. Negative 1 times 3x is minus 3x. Negative 1 times positive 1 is negative 1. Now, the middle terms will just cancel out, right? 3x minus 3x is 0. So you end up with 3x squared minus 1, and that's your answer. Okay, part B, 4a minus 5b squared. So this is the common mistake that students make. This is definitely not 16a squared, and then you go negative 5 times b times negative 5b, so 25b squared. No, that's not right, okay? But this is what students tend to do, so be really careful. It doesn't work that way. What you need to do is you need to think about what square means, right? Square means multiply by itself. So it's 4a minus 5b times 4a minus 5b. So then once you have this, written out, then you expand, right? Distribute like that. Okay, just like the way we did it earlier there. So now this is going to be 4a times 4a, 16a squared. 4a times 5b is negative 20ab. Negative 5b times 4a, that's also negative 20ab. And then we have negative 5b times negative 5b is 25b squared. Collect like terms, we have 16a squared. The middle two, when you subtract them, you get negative 40ab plus 25b squared at the end. Okay, so be careful. Okay, you have to make sure you expand and then distribute. Okay, part C, so this is the one I referred to at the distributive property part there. We have a binomial times a trinomial. So you need to expand or distribute. 3x times negative 2x squared is negative 6x cubed. 3x times 5x is 15x squared. 3x times 1 is plus 3x. And now you deal with the second term. Negative 4y times negative 2x squared is plus 8x squared y minus 20xy, and then finally minus 4y. Collect like terms. Do we have any actually? No, we don't have any like terms, so that's the answer. Okay, why don't you try part D yourself, see if you can do it. You should be able to do it. Okay, so I'm assuming you finished it. I'm gonna do it quickly here. 3xy times 1 is 3xy. Okay, so 3xy times xy squared, this is going to be negative 3x squared y cubed. So again, recall from previous chapter, when we multiply power with the same base, so like x times x, we add the exponents, y times y squared, same base, so 1 plus 2, you got an exponent of 3. Okay, so that's how I get that to x, y squared. Again, there's no like terms, so then that's it. Okay, so that's what we did in Math 10. Now, we're going to do something similar except that we are now going to do it with radicals. Okay, so first of all, we're going to do it with numerical radicands. Okay, so here is again binomial times binomial, but with radicals. Okay, so we are going to multiply, but the way to do it is exactly the same. You just multiply, distribute. 4 cube 3 times 4 cube root of 3 times cube root of 3. This is going to be 4. So cube root of 3 times cube root of 3. Anytime you have a square, okay, why did I say cube root? Square root of 3 times square root of 3. Okay, must be the 3 that throws me off there. Okay, so anytime when you have a square root multiplied by itself, this is just going to give you a 3. And the reason is because square root of 3 can be written as 3 to the power of 1/2. And square root of 3 is again 3 to the power of 1/2. When you multiply powers with the same base, you add exponents, so 1/2 plus 1/2 is 1, and that's why it's just 3. Okay, so root 3 times root 3 is going to be 3. Now we have for root 3 times negative 3 root 2. So first of all, 4 times 3 is 12. So, well, it's negative 3, so negative 12. We have root 3 times root 2, that is going to be root 6. Okay, so when we multiply radicals, you are going to multiply the radicands together. Okay, and then we are going to continue to the next two terms here. So 2 root 2 times root 3. So that's plus, both are positive. 2 is multiplied by the 1 here, written in the front. Okay, so 2. Root 2 times root 3, again, is root 6. We have 2 times negative 3, that's negative 6. Root 2 times root 2, again, that's roots, square roots multiplied by itself, so that really just get rid of the radical sign. So 2 there. We have 4 times 3 is 12. These two terms are like terms. Negative 12 root 6 plus 2 root 6 is negative 10 root 6. We have 6 times 2, which is 12, minus 12. So then 12 minus 12 is 0. So your final answer is negative 10 root 6. Okay. Part B. I probably should mention this too, hey? Back in part 8 in the warm-up section, this is what we call the difference of squares, 9x squared minus 1. This, again, is the difference of squares. When you factor that, you get 3x minus 1 times 3x plus 2. Or sorry, 3x minus 1 times 3x plus 1. It's just off by the, I mean, they're different only by the signs. One's positive, one's negative. Okay, so this, you can see that's a root 5, that's a root 5, that's a 10, that's a 10. This is going to end up with a difference of squares. Okay, anyways, root 5 times root 5 is a 5. So the special thing about this difference of squares, I'm going to do it this way anyways, but you'll notice something, right? Root 5 times root 10 is positive 10 root 5. We got negative 10 times root 5, that's negative 10 root 5. Finally, negative 10 times 10 is negative 100. Notice how these two terms, the middle terms, they just cancel out, right? Because again, it's a difference of squares. So they will always just cancel out themselves. So we end up with 5 minus 100, which is negative 95. Okay, so there are two questions for you to practice. Good luck. Okay, so I'm assuming you finished it. For the first one, I'm just gonna actually, I finished the first line already. You might think, okay, well, there is no like term, so I'm done, okay? So be really careful. Sometimes you're not quite done yet, okay? You actually need to simplify first. So 2 times 6 is 12. It's not a problem. This is root 18, which can be simplified, right? Root 18, we'll do it on the side here, is same as root 9 times 2. Square root of 9 is a 3. So we actually end up with 3 times 10, which is 30, root 2. Okay, so that's how you change 10 root 18 into 30 root 2. You can simplify that. Root 12 is the same thing as square root of 4 times 3. Root 4 is a 2. 2 times 6 is, sorry, 2 times negative 3 is negative 6. We still have the root 3 there. And then for the 15 root 6, there's nothing we can do. Okay, so we just copy it down. Now we simplify every single radical and none of them are like radicals. Then you can say, okay, this is the final answer. Okay, so be careful. Sometimes when you reduce it or simplify it, you end up with like radicals. In that case, you need to collect them. Okay, but in this case, we don't need to because they're not like radicals. Okay, Part D, I'm going to quickly do it here. Root 3 times root 3 is 3. This is going to be, okay, notice these are the same. So the only thing that's different is the plus sign, minus sign. What that tells me right away is that this is going to end up with a difference of squares. I don't need to multiply these two because they will just cancel out themselves. So I'm going to go ahead and do the last two. 2 root 5, negative 2 root 5 times 2 root 5. That's going to give me negative 20. Okay, so that's negative 17. Okay, so again, 2 root 5 times negative 2 root 5. This is going to be 2 times negative 2, which is negative 4. Root 5 times root 5 is 5. That's how I got my negative 20. Okay, so that's without variables, just numbers. Okay, and obviously we are not just going to deal with numbers only, so we are going to be looking at variables. So I'm going to show you how to do it right here. So now we're multiplying with variables. Okay, so but same thing. Okay, the principle is always the same. I mean, you're only dealing with variables now. Okay, but it's the same thing. Okay, first of all, it says identify the variables. The values of the variables for which each expression is defined. I think this is usually where students get confused about, and that's why I'm going to do this again. We did this in the first lesson, but I'm going to do more here. Okay, so the radicals that I see here are the root x and root x. Okay, so again, it's a square root, which means I cannot square root negatives, which means x has to be greater than or equal to 0, and that's how you define the variable. So then everything is defined. Okay, so then we're fine. Now we are able to do our carry our calculations. So again, 2 root x times 4 root x. 2 times 4 is 8. Root x times root x is x. We have 2 root x times 2, that's 4 root x. Negative 3 times 4 root x is negative 12 root x. Negative 3 times 2 is negative 6. Collect like terms, 8 times x, nothing we can do about that. 4 root x minus 12 root x is negative 8 root x. Minus 6 is still just minus 6, and that's your answer. Okay, but this is how you define the variable, so then everything is defined. Okay, part B. So I look at this again, I see square root of x, square root of y. That just tells me that x has to be greater than or equal to 0, and y has to be greater than or equal to 0. And everything else will be fine. Okay, so now I can actually expand this and simplify. So root x times root x is x. Root x times 2 root y is 2 root xy. Oh, here we go. Difference of squares. I didn't even realize that. But anyway, well, so I'm going to multiply anyway because I did it already. They're going to cancel out, as you can see, right? 2 root xy minus 2 root xy is 0. We have negative 2 times 2 is 4. Y, square root of y times square root of y is just y. Okay. Plus. Now this, be careful, which I showed this earlier. This is a perfect squares. So we need to actually expand. So I'm going to do it on the side because you know what, I'm not going to do it on the side. I'm going to write it down right here. So it's 3 root x plus root y times 3 root x plus root y. I'm going to click like terms right here. I just did. Okay, those two cancel out, so I end up with x minus 4y plus. Now I'm going to multiply. 3 root x times 3 root x is going to be 9. Root x, 3 times 3 is 9. Root x times root x is x. And then we have 3 root x times root y, so that's going to give us 3 root xy. Oops. And so that's that one. We have root y times 3 root x is going to be 3 root xy again. Root y times root y is just y. Okay, finally I can collect all the like terms together. That's x plus 9x is 10x. Negative 4y plus y is negative 3y. We have these two together, right? 3 root xy plus 3 root xy is 6 root xy. And that is your final answer. Okay, so give it a try for the next two questions and see how you do. Okay, so here are the answers. One thing I need to again address is this portion. This again is the difference of squares when you multiply them out. So I know the middle terms will get cancelled out, so that's why I don't have middle terms here. I just Didn't even bother multiplying them. Another thing to be careful is the minus sign here, right? Remember, it's minus of these positives. That's why 9 minus 1, right? It's 8, not 9 plus 10, okay? Be careful. Yeah, so those are the things you need to watch out for. I should probably define my variable, which I haven't done that yet. A is greater than or equal to 0, x is greater than or equal to 0, and y is greater than or equal to 0. Okay, so that's how you multiply, okay? You don't always have to write these unless I ask you to, okay? It's good to write them down, I suppose, but you don't have to. Okay, that's multiplying. Now I'm going to show you rationalization. Okay, rationalizing a monomial denominator. So in math, we mathematicians do not like to have radicals in the denominator. Okay, 1 over root 2 is not what we wanted. Okay, we don't like to see radicals in the denominator. So what we do is we rationalize it, and then this becomes this. Okay, now the question is, well, how do we do that? Okay, so how we rationalize monomial denominator is we simply multiply by that radical itself, because we know that root 2 times root 2 will simply becomes a 2. And you can see we do not have any more radicals in the denominator, and that's how I got root 2 over 2 there. And I can do this because root 2 over 2 is 1. Sorry, root 2 over root 2 is 1. So I can multiply by 1, and that's fine. Not a big deal, right? I can actually multiply by 1. That is okay. Okay, so that's how you do it. Rationalize the monomial denominator. Okay, so I have 2 questions I'll show you, and then you get 2 practice questions to do. So again, you can see this is a one single term, right? In the denominator, one single radical. In that case, to rationalize this, again, you do not want to have a radical in the denominator. So to rationalize this, you simply multiply by root 5 over root 5 in this case, because root 5 times root 5 in the denominator will give you a 5. Okay, now we just need to multiply. 3 root 5 times root 5 is 3 times 5. Negative 1 times root 5 is negative root 5. So then this is going to be 15 minus root 5 over 5, and that's it. Final answer. Okay, part B, again, single radical in the denominator. You multiply by root 12 over root 12. So in the denominator, you end up with 12. You get 2. Root 3 times root 12 is root 36. Minus 7, root 5 times root 12 is root 60. Okay, 5 times 12 is 60. We can then simplify this. Root 36 is simply just 6. So we have 2 times 6, which is 12. 60 is the same as 4 times 15, right? So this is same as 2 root 15. So negative 7 times 2 is negative 14, and root 15 is just root 15. There's nothing we can do about that. Okay, there's no more perfect square factor there over 12. And now you can see that's 12, that's 14, that's 12. We can reduce it by dividing everything by 2. So you get 6 minus 7. Root 15 is still root 15 over 6. So that's another place where students make mistake. You try to divide by 2 for everything, right? Including the 15. No, you don't. You just divide the 14. Okay, it's like 12 minus 14x divided by 12. You just reduce this by dividing it by 2. You don't divide x by 2, right? You already divide 14 by 2. Okay, so be careful. You don't change the radical there. Okay, so those are the examples. Try these 2. Okay, so that's the answer for the first practice question. Okay, so hopefully you got that one right. I started with part B. So again, that's what you end up with when you multiply by root 18 over root 18. Now, again, I'm going to show you one more time. Root 36 is simply 6. So 6 times 6 is 36. You need to simplify root 54 first. Okay, root 54 is same as root 9 times 6. And 9 is a perfect square factor of 54. That's why I chose 9. And that's going to be 3 root 6. So we have 4 times 3 is 12. So 12 root 6 here over 18. And now again, because these 3 numbers are even numbers, we can actually reduce this by divide. Actually, we can divide by 6 here. So 36 divided by 6 is 6. 12 divided by 6 is 2. Again, you do not divide the radicand by 6 as well. Okay, only the Is that even a coefficient? A coefficient should be in front of a variable. It's not in front of a variable. Just divided by that number in front of the radical sign. Okay, there you go. So that's as simple as it gets. It does not. You cannot simplify that even further. Okay, so that's it. Okay, so that's how you deal with radicals in a denominator with one single radical in a denominator. Okay, now that's not always the case. Okay, that's not always the case. Sometimes you will end up with binomials like this: 3 root 2 plus, I don't know what happened to the root sign there, 3 root 2 plus root 5. Okay, so that's the binomial. So in this case, what you do is you multiply by the conjugate. Okay, so the conjugate is this, right? If you have a plus b, the conjugate would be a minus b. So basically it's the same thing except that you put a minus sign there. And why do we do that? Well, recall from earlier examples, if we multiply this by 3 root 2 minus root 5 over 3 root 2 minus root 5, you can see these two are basically the same thing except one is a plus, one's a minus. So what that does is that it's going to create a perfect, the difference of squares. So the middle terms will cancel out. I'm going to show you everything in this first example though, okay? So I'm going to multiply the top. 2 root 5 times 3 root 2 is 6 root 10. 2 root 5 times root 5 is minus, okay, it's negative 2 times 5. And then we have root 3 times 3 root 2, that's negative 3 root 6. We have negative root 3 times negative root 5, that's a plus root 15. Okay, so that's the numerator. Now we can carry on to the denominator. 3 root 2 times 3 root 2 is going to be 9 times 2. 3 root 2 times negative root 5 is negative 3 root 10. And now we do the second term there. Root 5 times 3 root 2 is going to be positive 3 root 10. Finally, root 5 times negative root 5 is negative 5. Notice, negative 3 root 10, positive 3 root 10. Again, that's why we multiply by the conjugate. So the middle terms gets cancelled and we end up with no more radical signs. Okay, anyways, now we need to collect like terms. So 6 root 10 is 6 root 10. That's minus 10 there. That's minus 10, not B10, minus 10, minus 3 root 6 plus root 15. There's nothing you can simplify in the numerator, okay? So then that's it. That's all you can do. And like what we did, we collect the middle two, they just cancel out. 9 times 2 is 18, 18 minus 5 is 13. And there's nothing you can reduce, so that's your final answer. So that's how you deal with binomial denominator with radicals. Okay, I will give you a hint for A, because we have radical here, but this is not a radical. Okay, so but you do the same thing. Okay, as long as it's a binomial and it has a radical sign, what you do is you multiply by its conjugate. So you are going to multiply by 3 root 2 plus 4 over 3 root 2 plus 4. Okay, so give it a try for both A and B, and I'll show you the answer in a bit. Okay, so I finished the first two lines for part A. So I just want to, again, anytime you have these expanded, make sure you reduce or simplify, right? 6 root 12 is the same as 12 root 3. Okay, so root 12 is 2 root 3 times by 6. That's how you got 12 root 3. Again, now notice every single term, the number in front of the radical signs or just the constant itself are all even numbers, and our denominator is also even, so we can actually divide everything by 2. So our final answer should be 6 root 2 plus 8 plus 6 root 3 plus 4 root 6. And the 2 just disappeared because we just divide everything by 2 there. Okay? Alright. I'll give you another few minutes to do part B. Go ahead. Okay, so I finished the first two lines. So here, multiply by the conjugate. Again, the conjugate means it's exactly the same as that, except we changed the plus sign into a minus sign, right? This was a minus sign. We turn it into a plus sign when we multiply. That's the conjugate, okay? So here, it's a plus sign, so the conjugate is going to be a minus sign. So again, I multiplied, I expanded. Notice again how I changed these two. Okay, so again, you need to simplify root 12 and that's 2 root 3, and 2 times 12 is 24, and keep the root 3. Root 18 is 3 root 2, so 3 times 8 is 24, and keep the root 2. Now everything can be divided by 6, right? That's multiple of 6, multiple of 6, multiple of 6, multiple of 6. So you can, and that's also multiple of 6. You divide everything by 6, you end up with root 6 minus 2 minus 4 root 3 plus 4 root 2. And that is your final answer. Okay, so that's how you multiply and divide radicals. Let me know if you need some help. You can rewatch the video, parts of it if you needed to. Yeah, now you can do some practice questions in the book. Good luck.